So each complexity class here follows a number of conditions, or has a number of conditions that define it. So P is defined as being the class of all problems that can be solved in polynomial time on a deterministic RAM. And Nexptime, for example, is defined as the class of all problems that can be solved in exponential time on a non-deterministic RAM. Now, when you want to arrange those classes into a sort of hierarchy, then you always have to think about which conditions are more restrictive than others. And I hope it's clear by now that determinism is more restrictive than non-determinism. So basically we can say non-determinism is stronger than determinism. Of course, this is very hand-wavy, so don't show this to a theoretical computer scientist, but for here it's okay to think about it that way. Now, what about exponential time and polynomial time? I think that is a very clear one. So exponential time clearly should give you at least as much power as polynomial time. And this basically gives us the hierarchy, because polynomial time is clearly the most restrictive one, and non-deterministic exponential time clearly the most powerful one. So we can already say here that P goes into the very inner circle, whereas Nexptime goes out here. Now, what about NP and exponential time on a deterministic machine? When we talked about non-determinism, we already found out that polynomial time non-determinism can always be simulated in exponential time determinism, which means that exponential time on a deterministic machine is at least as powerful as non-deterministic time on a polynomial time machine. So NP goes into the second circle here, and Exptime into the third.